A surge suppressor is a device for preventing sudden excessive flows of current in a circuit. It doesn't matter that you don't know what a surge suppressor is. It is made of a material whose conducting properties are such that the current flowing through it is directly proportional to the fourth power of the potential difference across it. Let's get this information down straight away. So they said that the current I is proportional to the fourth power of the potential difference across it. Boom, we've got that information down. To the fourth power of the potential difference across it. If the suppressor dissipates energy at a rate of 6 watts, okay, when the applied potential difference is 230 volts, blah blah blah. So this is our case 1. Let's get that information down. So they're saying in case 1, or like, this is the first example, P is equal to 6 watts, and at that same time they've said that V is equal to 230. So I'm going to say V1 is equal to 230 volts. Now they said, what is the power dissipated in this second scenario? So we're looking for power 2. We're not sure what it is yet. When the potential difference rises to 1200 volts. V2 equals 1200 volts. Okay, so we've been given this equation, which is I, V, and I've been given something to do with P and V. Obviously, therefore, we're going to need to use P equals IV. So I'm going to go right ahead and add into this a constant. We don't know what it is, but there's some sort of constant now. That's what this proportionality means. I'm then going to, so this is going to be our equation 1. I'm then going to write down another equation which will be useful, which is going to be P equals VI. And that's going to be our ec2. And then I'm going to put in sub ec1 into ec2 gives P equals VK V to the 4. Now we've got an equation which doesn't involve I, which is great because we don't have any information about I. Note that this is equal to K V to the 5. So now we can look at case 1. P1 equals 6 equals K, and then 230 to the 5. Therefore, we can work out what K is. So we'll say K is equal to 6 over 230 to the 5. And now we look at case, so this is like case 1, and this is case 2. We'll say P2, which is our mystery, is equal to, using this equation, K 1200 to the 5. Then we've got here equation 3, sub ec3 gives P2 is equal to, I'm actually going to put it on the line below because it's easier for you to see. P2 is equal to 6. And then I'm going to move that slightly to the right. So we'll have 1200 to the 5 over 230 to the 5. So that's 6 over 230 to the 5 I've brought over there. Notice I didn't bother calculating it yet because there's no point. It's easy enough to write that. It's going to be some massive number, especially if I did 6 divided by that. My calculator probably won't even display it. So I'll just leave it as it is for now. But I did need to sub it in order to be able to get to this point. I don't like subbing in until the end. So now this is great because I can change that to be 1200 over 230 and then all to the power of 5 because you can do that with powers. Then I can start cancelling these out, and now I'll do use my calculator to work out 6 times 120 over 23 to the power of 5. So I just put that into my calculator, and the raw figure I get is 23196 and then some stuff. It's power, so the units are watts. That's a ridiculous level of detail for me to put it in, so I'll just check the question. This is to two significant figures, this is to two significant figures, therefore I'll give my answer to two significant figures. And then I'll underline it so it's easy for the examiner to see my answer, and I'm going to note that that is the answer to two significant figures, not 5. That's the end of this one.